first thing, whenever you have a rational function and you're looking into like discontinuities or graphing, like it's usually always helpful to go ahead and just simplify this. So there's really nothing I can do in the numerator. However, in the denominator, I can look into this as factoring, like, right? So, how could I factor this? So a couple things I look at the last number, which is positive, right? So therefore, I'm going to take the factors of 8 and I'm going to add them. So what factors of 8 are going to add to give me a 6? Forget about the negative for a second. So what two factors add to 8? Well, let's just think of the factors of 8. 8 and 1 and 4 and 2. Well, obviously 8 and 1 go to 9, so 4 and 2 give me 6. Cool. So therefore, I have an x and 4 and an x and a 2, right? Now we need to determine, are they positive or are they negative? Well, obviously a negative times a negative, they have to both be the same sign, right? Because a positive times a positive is a positive, and a negative times a negative is a positive, right? That's what happens when the last number is going to be positive. So since my middle term is going to be a negative, then that means these both have to be negative. So therefore, this is factored. Okay, so therefore, I have this as an x minus 2 times an x minus 4. All right, so the next thing I want you to recognize here is whenever I have like 4 divided by, let's say, 4 times 3, right? These 4s divide out, right? You could obviously rewrite this as 4 over 12, right? Or you could just reduce this, right, to a 1/3. So the important thing is whenever things are separated by multiplication, you can apply what we call the division property, which means terms are going to divide out. So I'm going to put these in parentheses just so you can see that these are exactly the same, and therefore they can be divided out because these are separated by multiplication. So therefore I have g of x is equal to a 1 over a x minus 4. Okay, so now let's go and talk about the discontinuities. So discontinuities are going to be values that are not defined for your function. That means they're not going to be in the domain. So what numbers are not in the domain of a rational function? Well, when we just have for a rational function, those are going to be the values that are going to make the denominator equal to 0. So we have two values that made the denominator equal to 0. We had x equals 2, right? That made the denominator equal to 0. But what happened? That got divided out. So if you go back to the original problem, right? If you go back to the original problem, 2 is still going to make the denominator equal to 0. And again, like just plug in your work. Like you can look at it in factored form, right? 2 minus 2 is 0. 0 times x minus 4 is 0. So before I even simplified it, 2 still makes the denominator equal to 0. However, you can see that it gets divided out, right? You can divide it out. You can simplify it out. So that's what we call a removable discontinuity. So a removable discontinuity is a whole. So I can say at x equals 2 is a whole, which we call a removable discontinuity. Now, the other number that gives me make my denominator equal to 0 is going to be a 4, right? Because when you plug in 4 in for x, 4 minus 4 is 0, and that's going to make the denominator equal to 0. However, that could not be divided out, right? So that is what we call a non-removable discontinuity, which is a vertical asymptote. So at x equals 4, we have a asymptote. Okay, so there you go. Hopefully that was helpful.